Welcome to the talk. Thanks a lot for showing up. For people who traveled, like myself, I hope you had a comfortable travel. And for the folks, I hope you had a good sleep and were able to catch some breakfast. I couldn't warm my bagel up, so mine was a different experience, but I hope you were able to. My name is Aman. I am one of the developer evangelists with Akamai Technologies. The company is based out of Boston, offices around the world. I work out of the Bangalore office, but we have an office in SF too. What we're going to talk about today is about HTTP2, how it works on an overview level, what are the benefits it promises, and how Android developers can use it. So before we begin, a bit about what HTTP2 is. So knowing a little bit about history would be good at this point. We started off with HTTP 0.9, and which eventually evolved to become HTTP 1.1 at 1999. And since then, pretty much, we are using HTTP 1.1 for doing everything. But the web has changed. The needs have changed. Back in 1999, we were mostly serving HTML. Now there are more things that need to be served on the internet. There are more devices now. They are not just mobile devices. There are cars. There are IoT devices. There are refrigerators. The data that transfers over the wire is not just HTML anymore. It's scripts, objects, images, and lots of other stuff. JSON, you never know. So we kind of kept pushing and arm twisting HTTP 1.1 so far to do the kind of optimizations that we would want to have, while HTTP 1 was not actually designed to withstand all of those changes. So HTTP 2 was finalized in 2015 as a successor to the protocol called SPDY, SPDY. I guess quite a few would have heard about it. It was an effort from Google as well. So HTTP is the successor of, HTTP 2 is the successor of SPDY, and it was released in 2015. And the reason I took this as a topic because in the Android world, I did not see a lot of people using HTTP 2. That's a different matter, but because when I started researching, I found out why. We will talk about in this presentation why that happened. Before we begin, why should you use HTTP 2? There are three most important things I would like to tell as the reason why you should move on to HTTP 2. Performance, the changes that HTTP 2 proposes makes the performance really, really good. In many cases, complexity is reduced because HTTP 2 is not really very verbose, and you don't have to do all of those arm twistings or workarounds to get the performance gains that you used to do with HTTP 1. So once that optimization effort goes down, your complexity automatically reduces, so you're able to build more robust applications. And the third would be efficiency. The kind of performance gains and the way HTTP 2 implements itself and the web servers and the clients interact using HTTP 2, it automatically makes everything more efficient and the resources can be used more efficiently. We'll find out more about why that happens and how that happens, but if you want to take away two big words on why you should use HTTP 2, I would leave you with speed and security. So HTTP 2 started with a few goals. HTTP 2 wanted to improve the perceived latency. The perceived latency is in terms of what users perceive as latency. So let's say you have an app or you have a website. When the page is visually loaded for the users is when they think that, okay, this website is now loaded and I can work with it. In the meanwhile, you could still be loading scripts or other metadata or other futuristic cached objects in the background which users don't know about. So your actual time to load might be different, but the actual perceived latency for users could be different. Take a simple example. You have a recycler view. 10 rows of recycler view related data has been downloaded from the internet, but only 3 of them have been prepared and put on the screen. So for the users, the time it took to present those 3 rows, including rendering and network call, is the perceived latency, no matter whether you are still caching the objects which will appear on the 9th row, for example. So HTTP 2, with its performance gains, wanted to improve the perceived latency. HTTP2 also wanted to address the problem of head-of-line blocking. So what used to happen is HTTP 1.1 uses TCP connections for all the requests, so single TCP connection for all different requests. In the beginning of time, when HTTP1 came into picture, you wouldn't have so many objects to download on the client. But as the time progressed, there was too many things being sent from server to the clients. And since it's TCP, unless one request or one connection one connection finishes, you won't be able to make a new one. So that was one problem that HTTP2 tries to solve. HTTP2 also wants to enable parallelism without creating multiple connections. So a bit of a context here. When you talk about clients, there can be web browsers and there can be mobile apps. On mobile apps, we typically use an HTTP stack like OKHTTP. OKHTTP typically puts a queue of requests. If you have multiple requests going on, it puts all of them in queue and does a sequential request of all of them. Browsers, what they used to do, they used to open multiple parallel TCP connections to web server as long as they're on the same domain. And then this multiple parallel connections could be 6 connections, 7 connections at once, and then download all the different objects and try to achieve parallelism. HTTP2 tries to reduce and remove that problem, at least for browsers, where one single TCP connection can be used for multiple requests and multiple responses. So HTTP2 tries to adopt a streaming model of sending and receiving data. Okay, we'll talk more about that later in the deck. Now, since HTTP2 is not something that you can just one day switch on and forget about HTTP1, one of the goals was to also define how the servers who are currently using HTTP1 will work with HTTP2. So how do you actually still have HTTP 1.1 and 2 both running together without having any problems? That was another goal. Similarly, another very big goal was to help developers not make too many changes to migrate to HTTP2. So you could still remain with the semantics that you were using while you were using HTTP 1.1 and just do very few or minimal changes to move over to HTTP2. Talking about a few features, multiplexing of request, stream dependencies, TCP optimizations, these are a few biggest features that we'll be talking about one by one. Let's talk about multiplexing of requests. And we just talked about requiring multiple TCP connections for multiple different requests. HTTP2 uses one single TCP connection to fire off multiple different requests and starts receiving their responses. So it's async by design. Whether you're a mobile app or you're a browser, you are sending and receiving data in an async mode. So that helps in reducing the time that you take to establish new TCP connections. And in some situations, this can really improve your performance. Next would be stream dependencies. So now when you are making multiple requests for one single TCP connections, you might want to give priorities to one of the resources or requests. So you can make another request and say, this is the resource I want to be delivered first. So the server, instead of sending everything in a random order, honors that priority that you have set and sends down the requests that you have requested as a priority. The TCP optimizations that we just talked about uses one single connection to do all of these requests and responses. It saves a lot of time because obviously there are no multiple connections. And if you look at the diagram, if it's visible to you, this is a stream model where there's an incoming stream and there's an outgoing stream, and the data continuously keeps flowing around. This is one of the biggest features of HTTP2, where everything is binary. The headers and the body, everything is binary and not clear text. This is one of the things that makes HTTP2 backward incompatible. This is why it is called HTTP 2.0 and not HTTP 1.2. So what used to happen so far is you would either encrypt over HTTPS or not encrypt over HTTP, but your data would be sent in clear text. Now what happens? The data is converted to binary before being sent over the wire. So that has a few improvements. You are less likely to make mistakes if data is binary, and it's more efficient to transfer and transcode it later. Then there are some header optimizations that are very useful. So what used to happen so far, whenever you are making a request or response, you would have noticed that there are some redundant headers. There are some things like method, what method you are using, what's the user agent. You keep sending and receiving it all the time without them changing. So what HTTP2 does is, first of all, it kind of maintains a history of the header values for a single session, and whichever header is being repeated, it doesn't start sending it over the wire for that session. So in this example, if it's visible on the back too, the request number 1 has all of these fields, and the request number 2 has only a new field called path. So when the response is sent down the wire on a stream 3, only the path changes are included in it, and all the old changes are implicit, so they are not included in the header. So the client and server, they actually interact with each other and discuss that, okay, this is the only new field, rest of the things are older, I'll figure out. So you are first of all sending and receiving fewer fields, and then they're compressed and they are binary. So you're saving a lot on the header too. Now why this? Because in some situations, your headers become just too big. A typical TCP packet is like 1.5 kbs, and sometimes the header itself would be more than 1.5 kbs. So if you're just spending multiple TCP packets just to transport the header, that's a waste of the bandwidth. So this particular feature tries to solve it. Then this is one very good thing called server push, which I got confused with when I started studying about it. This is not to be confused with the push messaging that we use in Android or mobile devices. This is actually something where you request a resource from server. The server knows that there are 5 more resources that you will need in future, and it sends them back without you asking for it. So take an example. Again, you're loading a list of 10 users in your recycler view. All of them would have avatars. So the first request is to your API to get the JSON blocks for all of these users. And obviously, the next requests are going to be to fetch those pictures. So the server can know this, and server can send all of these picture objects in advance to your app. The job of your app would be to cache them so that when the user is scrolling and the images are needed to be loaded, the objects are served from the cache and not from the network. A lot of our libraries are already doing it, like Glide and Picasso and Fresco, but they still need at least one request to be going through the wire before caching it, right? But here using server push, you can eliminate sending that request, eliminate the time taken in TCP connection establishment, and just send it out from the server without the clients asking for it. This is also not very well implemented yet, and there is no best practice that I could find on how to send a server push or how to receive a server push. So I think it's an area that's still getting evolved, and in the future, we'll see better things coming out of it. With all of these niceties, there are definitely some things which are currently a bottleneck. The biggest of them is the TCP, the reliance on TCP. So what happens is, if you start losing packets over TCP, then the benefits that you gain from HTTP2 start to slow down, start to come down. My colleagues at Akamai did a research, and they found that on mobile devices, when you're on cell networks, if the packet loss is increasing more than 2%, then the HTTP2 gains that you are getting, they also start coming down. At a point, I don't remember the number yet, but at a point, you are essentially not gaining anything much if you are on HTTP2, and there are a lot of packet losses. So the bright point is HTTP3, which will be based on the QUIC protocol, is going to come out somewhere next year. So that is going to resolve all this. QUIC protocol doesn't rely on TCP. It relies on UDP. So a lot of things that the TCP protocol has a problem with, QUIC won't have it. QUIC is already available. It was introduced by Google back in 2012 and then released as an experimentation in 2013. And you can still play with it. You can download a library. I think the library is called Cronnet. and include it in your app. If your server supports it, then you can go ahead and try the improvement that Quick does. So again, HTTP 3 is HTTP 2 over Quick, going to come out somewhere in 2019. By the way, if you want to check if any of the sites support HTTP 2, I'll be telling you about a handy tool that you can use. Now, how to get started, how to begin using HTTP 2 on your backend servers and your applications. So quick things, we'll first look at how to get HTTP 2 running on backend servers. You may have your own APIs, or you may be using a third-party API or Firebase. So if you have your own backend, almost all of the latest web servers like Apache or Tomcat or even Microsoft IIS, they support HTTP 2. All you need to do is just somehow get your servers upgraded. I won't delve into that. And they'll start supporting HTTP 2. There are CDNs. All of them support HTTP 2. My employer, Akamai, we were one of the first major CDNs to support HTTP 2, along with supporting server push. So most of the CDNs are already supporting HTTP 2. And yeah, if you want to check, interesting. The click didn't work, sorry. So the Apache, the Tomcat, and the MSIS, all of them support HTTP 2. You just need to get them upgraded. Akamai is one of the major CDNs to support HTTP 2 and server push, and all of the other major CDNs, whichever you're using, they do support HTTP 2. If you want to check if a web server supports HTTP 2, this is a tool by KeyCDN. You can just go and test if the APIs that you are using are HTTP 2 enabled. Quick fact, most of them you'll find they are already supporting HTTP 2. An example of one service which doesn't support right now is www.github.com. So I'm not sure if it's just the website front end, or if their API support it, or if they're the push or pull model that we do, if that supports it, but at least www.github.com currently doesn't support HTTP 2. So I just wanted to make sure that this tool is working, because it was saying supports to all the websites that I was using. So one of the things that I found was the github.com. It doesn't support HTTP 2 yet. And then Firebase hosting supports HTTP 2. If you're hosting your objects on Firebase, there is a support for it. What I couldn't find the support for is whether the Firebase SDK is supporting HTTP 2, but I'm making a guess, and I'm assuming that since it's Google and they are the pioneers in this field, they will be supporting, or at least doing the best thing possible to make the transaction between your Firebase SDK and Firebase server the fastest possible. I also couldn't find whether the single sign-on or social sign-on SDKs support HTTP 2, so that continues to be an area of research for me. Now, once you're done on the backend servers, what do you need to do to support HTTP 2 on Android? Easiest, upgrade your OKHTTP dependencies to 3.9.0 or above. So OKHTTP above this version supports HTTP 2 by default. There are some caveats, we'll discuss about them in this talk. So if you're using any of the image loading libraries, just have them use OKHTTP version 3. Same goes for the networking libraries. And the thing to note is it will work only on TLS connections. This was not by design. HTTP 2 spec doesn't actually ask you to use HTTPS or TLS connections, but all of the major browsers, and including Android, is now asking every request to be HTTPS. So why OKHTTP 3? I think I'm going to confuse a lot between HTTP 2 and OKHTTP 3 because of the names being so similar. So yeah, 3.9.0 supports HTTP 2 right out of the box. The other status of support is HTTP URL connection currently doesn't support HTTP 2. I'm guessing the reason is, even though they're based on OKHTTP, they're based on an older version. So hopefully with future Android releases, this should get resolved. For retrofit, if you're using the latest version, they're already based on top of OKHTTP 3, so they will be using HTTP 2. Wally depends on the default HTTP stack. You can change the HTTP stack to become OKHTTP 3 so that your requests are going on S2. Similarly, for image loading libraries like Glide and Picasso, for Glide, you need to add a separate dependency in your build.gradle. I'll show how. And for Picasso, the version 2.7 is automatically based on OKHTTP3, so that it means it will support H2. So yes, if you are using Glide, all you need to do is add this integration in your dependencies, and you'll be good. So you may need to upgrade some of the dependencies, but code level changes will be pretty minimal. Now, what if you cannot upgrade to OKHTTP3? There is a workaround. You can use Jetty ALPN library. This is a screenshot of how you would do Jetty ALPN library on your test code. There's more information available here. We'll discuss what ALPN is, but a few things about this is this will let you make H2 request with your current code as long as your code is run on Android 5.0 or more. Okay. Now, what is ALPN? ALPN is application level protocol negotiation. What that means is before the requests are being sent and received over TLS, there's a handshake between your apps and the servers, or the client and the servers. During the handshake, ALPN negotiates which protocol is going to get used. So this was not available on Android earlier. That's why you need to use Jetty ALPN. But I think, I'm not sure about the version, but Google Play services now have their own ALPN inside it. And OKHTTP3 can support S2 only because they are depending on Google Play services ALPN. So as Google Play services continue to move forward and be downloaded and updated on more of the devices, I'm hoping that the support will increase. So a bit of a recap. Your hurl connection won't support HTTP2. OKHTTP does with a few things. There is a bug in OKHTTP right now which prevents all the requests from being sent over the same TCP connection. So it's still sending all of the requests as a separate TCP connection. It's still making a queue over it. It was supposed to get solved in OKHTTP3, but hasn't been yet. Like at least checked last night, it wasn't. I can give you the link of the bug. So hopefully when that gets resolved, we'll also start having pure multiplexing of requests on Android. Server push, I didn't find any of the examples of server push getting used efficiently on the web or browsers, let alone on Android. Most of the articles and most of the places which I found were people were complaining how tough it is to implement. So I'm assuming that in future there'll be more best practices coming around how to use server push. And one thing is why you should upgrade to HTTP2, because speed and security. So I coded a quick demo for all of you on Android app, but since it's OKHTTP3 based and all of them go through the same way, the differences are not too big to be shown. But there's another demo which can tell you the gains that you will have from OKHTTP3, from HTTP2. I'll quickly switch to my browser and show you the demo. So these are the links I can share if you want. So yeah, the image on the left will be loaded over HTTP1 and on the right will be on HTTP2. These images are composed of nearly 380 small tiles of small images. So when I actually refresh the page, it will show you how HTTP1 loads it in a sequential manner and how HTTP2 loads it in a very random but faster ways. So let me refresh the page. That's HTTP1, very linear. And look at how HTTP2 does it. The time it took, let me zoom this. The time it took was 3.29 seconds to load all of these tiles on HTTP1, and more than half the seconds reduced when you use it over HTTP2. So I was trying to replicate the same demo on an Android app, pretty much there. as soon as the OKHTTP resolves that bug, my code will start working. So I'll actually put it on GitHub. We are on github.com/akamai. It will be there for you to see. So these are the kind of optimizations and performance gains that HTTP2 promises for you. I don't think that web servers will stop supporting HTTP1 anytime soon. It will happen only when, let's say, the clients or the browsers start pushing for it, which may not happen in next 4 or 5 years, but it's always a good idea to upgrade to something which is coming in the future, because after this, there'll be HTTP3. And after this, you don't know what. And since we are developers of experiences which are mobile in nature, they need to be fast, they're more personal, anything that can make you deliver good performance is good thing. So that's HTTP2 demo. Getting back to the deck. All right. So yeah, a quick review and recap of what we did, what we talked so far. The features, the goals of HTTP2, the state of support on Android using OKHTTP, and how do you get started with HTTP2 on backend servers and on Android, and a quick demo to see HTTP2 gains in action. My research in this area still continues to progress. The things that I referred, because I'm a typical Android developer guy, this was a lot of science for me. So I did a lot of study using, this is my colleague's book. This is the primary source of all my knowledge so far. There is a very good introduction on developer.google.com in their web area. So I've linked there as well. If you like to read RFCs, RFC 7540 is what you should be looking at. And there are a few books, one by Daniel Stenberg and Ilya Grigorik, which will help you understand networking better and in turn make your app's performance better. If you have any questions after this thing, if you want to reach out to me, these are my coordinates. I will be in the Koblenz room for an office hour at around 1 p.m. So if you want to ask me anything about Akamai, CDN, Android, HTTP2, quick maybe, just jump over. I'll be there. And that will be it for me. I'll be able to take some questions here. I hope my little acquired knowledge so I will be able to help you. So thank you from my side.